right, guys, so I'm making this because we didn't get a chance to go over our unit assessment like we typically do in class. So just as a reminder, that's your best way of preparing for your unit assessment. And I'm just going to go through your review. Now, remember that this key is available for you. If you go to the online review, you'll see that there. So BCR 1.1, Lewis dots. Pretty much it's a skill that you need to know to be able to bond things. So yes, there's going to be questions on this, but not many. And the questions really that you need for this is mostly because of the bonding, mostly with 2.3. Okay, so now being able to tell the difference between ionic and covalent bonds. So obviously knowing what ionic and covalent bonds are, being able to identify, knowing that ionic is always a cation and an anion, most of the time metal and a non-metal, but there are exceptions to the rule. And same thing with covalent, 2 anions with 2 nonmetals, and again, some exceptions to that rule as well. And ways to also figure it out, ionics have no prefixes, so anytime you see a prefix, then you're going to have an ionic bond, or sorry, no prefix, ionic bond. Any prefixes, covalent bond. Being able to identify is going to be important. That'll be a question that you'll see. 2.2, knowing how covalent compounds are formed and the understanding of how the electrons are shared to form that bond. Knowing the names for covalent prefixes, those will need to be memorized. Then also being able to give the name if given the formula, or write the name if, or vice versa, write the formula if given the name. A lot of people ask about order here, like, do I have to know the order of the elements? The order will already be established for you in the stuff that I've been given. Now, just as a note, your 2.2 and 2.3 questions, those are going to be more like the combined assessment, where I'm not going to tell you it's ionic or covalent. You're going to have to, 1, identify, and then 2, be able to do the opposite, either name or write the formula. So ionic thing, understand that electrons are lost or gained, not shared anymore. And because of that electromagnetic charge, we will have that attraction between the positives and negatives. Rules for naming, the cation always comes first, then the anion. Never have prefixes again, but it does end in "-ide". Okay, so this question is one that students get a little confused about. Pretty much, if you look at this right here, this is what I give you. This is like if you were a teacher and someone wrote me the formula BA2 and 3, I would have to look at that and say, is that correct or not? And it is incorrect because your subscripts are incorrect because when you put these together, either using the Lewis dot or ionic charge method, like we did in Objective 2.3, you would see that you do not have a neutral charge. Okay, and also being able to name the compound is necessary to do. Remember, you always have that ion first, so always the metal, just typically the metal comes first. Again, just like I mentioned in 2.2 and 2.3, you're going to see things that are more similar to the combined assessment, so making sure you go back and look at that would be helpful. All right, 2.4, so this was all your marshmallow structure stuff. Pretty much you're just showing and identifying how these are different. So how are a molecular, which is covalent, and ionic structure is different, meaning like ionic, we used fluff to represent the electrical charges because the electrons are given and taken to create those opposite charges, and that's what they stick together for. Ionics can get infinitely large as long as you follow that pattern of positive, negative, positive, negative. And then, excuse me, sorry, I'm like so stuffed up. And then covalent structures, we used them as the toothpicks, and the toothpicks represented a shared pair of electrons between 2 atoms, and specifically that was carbon. And being able to be a little bit more geometric, they can get as big as they need to, but you have to keep more of that geometric pattern, not positive, negative, positive, negative. And why can carbon create so many different structures? Because they have 4 valence electrons, and that is something that is huge in the area of bonding. This isn't necessarily something I'm going to ask you on number 4, but it is the reason why carbon can bond with itself so many times. All right, BCR 3.1. BCR 3.1 and 4.1 are pretty big ones. So definitely make sure you're hitting that, especially your 2.2 and 2.3 if you're going to prioritize. 2.2, 2.3, 3.1, and 4.1 are your big guys. So understanding what part of the atom is involved. Specifically, we're talking about valence electrons. So any type of bonding, breaking bonds, creating bonds, switching partners, kind of like what you have here. Well, this one, you've created a bond. That is a chemical reaction because it's dealing with valence electrons. So identifying reactants and products, understanding that the big number is the coefficient. We can change those, but if I'm given an actual formula, I cannot change those unless I tell you put aluminum and oxygen together, and then you can. Understand the law of conservation and understand that atom's identity does not change because we only change the valence electrons. We will never have new elements form. That's different from nuclear reactions. All right, so balancing chemical equation formulas. You can expect to see some equations tomorrow, and be ready. I would say they're not super easy, but they're not super hard. They're kind of in the middle, so they're medium level. And then number 6, if I could give you any advice, I would make sure you could do questions like this. This is it's not exactly like, but it's very similar to the question in Station 5 on your endothermic exothermic lab, where you are given the words. You have to create the actual formula. Once you create the formula, then you can balance it out by coefficients in here. The biggest place where students miss is this, magnesium chloride. Magnesium chloride, because it has no prefixes, is ionic, so therefore it's not just MgCl. I have to go back to my understanding of ionic bonds and find out, okay, magnesium has a +2 charge, chlorine has a -1, therefore I need 2 chlorines to neutralize 1 magnesium. Or if you want to bring your electrons over, you would see that as well. Okay, so I could give you any hint tomorrow. I would say make sure you can do something like question 6. You can guarantee to see something like that. Okay, so exothermic, endothermic. Heat is entering the system, so be careful when you're talking about endothermic. So heat is entering the system, but remember, the system itself is where the compounds are, so we can't actually feel that. We feel the surroundings, so endothermics feel colder, while exothermic, also heat has to enter to start the reaction, okay? And then exothermic, heat exits the system into the surroundings, and when we take the temperature, when we feel the surroundings, that it will feel warmer. So take a look here. Endothermic is something that you would have on the reactant side. Exothermic, you would have heat on the product side. Number 1 is a trick question. I'm not going to give you something like that. Yes, you have to put a lot of heat in, but you get more heat out. So this is exothermic, but this is actually a fusion reaction, okay? 2 small atoms combined with a lot of heat and pressure. We don't see that to form helium and lots of heat. So higher temperature. Now, fission reaction, lots of heat on the exothermic, so it's releasing heat after the reaction. Same thing here, exothermic and endothermic, because heat has to be put in to start that reaction. So just be aware that you're going to be given situational things. Like I would give you data and say, all right, this happened. Is this an exothermic reaction or an endothermic reaction? Like I could tell you the starting temperature and ending temperature. I could say we had to put heat into the reaction to start it. All of those things would be fair game for endo and exo. And then 4.1, like I said, this is a big one. Understanding that the nucleus of the atom is involved, so that involves protons and neutrons, and that the identity does change when we're going through nuclear reactions. So nuclear reactions involve decay, fission, and fusion. All of those affect the protons. Protons are either going to be split up or put together. And when I affect the protons, I'm going to have different identities. Here, the amount of energy released, chemical reactions do not have as much. And then the big thing is making sure you understand the difference between electromagnetic force and strong force and how that relates to unstable and stable atoms. And also what it means if you're going down here for something to be radioactive. Pretty much that just means it's unstable. And then also if you're unstable and you're radioactive, you're releasing radiation. And radiation is just the energy that comes off of a nuclear reaction. It's just energy. 4.2. So now half-lives. You guys did a lot more of this we didn't focus a ton on this in class because you guys did a ton of it in sprint science, but you guys can expect to see more application questions just like you did on your objective assessment. And then number 3, as far as like carbon dating, I'm not going to have you explain this, but understanding carbon dating is a application of half-lives, meaning we can calculate the percent of carbon left in once living things. That could be plants, animals, anything that's once living. And if we calculate that percentage, we can calculate how long ago it died. And that's what carbon dating is. So it's just a prediction of half-lives. So you can expect to see graphs or charts tomorrow for half-lives. 4.3, make sure you know so go back to your lesson or your thing that you've done where you've created that whole Google Slides presentation where you have different uses of radioactive isotopes. Make sure you know those. Like, it doesn't have to be all 4 of them, but make sure you know a couple, like something that we use it for medicine or something that we use it for food. It doesn't have to be a super big, long explanation, just like your assignment wasn't, but you need to have the general idea. And then last but not least, fission versus fusion. You need to be able to generally explain the process, the type of atoms, identify reaction equations. One big one is fission will always have a neutron on the reactant side because you need that to start the reaction. And then usually a larger atom, but it's always going to have a neutron on the reactant side. And then also a list of examples where these occur. So making sure that you know those things. And then obviously understanding fusion needs a lot more heat needs a lot more to start the reaction. So therefore we also get a lot more out. Both of these are exothermic, creating a lot of heat and being released. So all of these general ideas. So it's a lot. I would say if you're going to try to focus on things, I would definitely try to focus on BCR 2.2, 2.3, 3.1, and 4.1. Those are some big question things that you would see. All the other ones I think are important, but just probably not as hit as much. It doesn't cover as much as well. There is a review game. The review game is the BCR, the Great BCR Race. It's what we did in class today. But if you didn't have an opportunity to either finish or start it, you can do that at home. Just choose the at-home version. All right. Let me know if you have questions. I will be here before school tomorrow at 6:45.